Alright, welcome back for another free response today. So we're going to be working with rates of change and intermediate value theorem. So we've got a cylindrical can of a radius of 10 millimeters that is used to measure rainfall in Stormville. The can is initially empty. So say this will be S of 0 is 0. And rain enters the can during a 60-day period. The height of the water in the can is measured as S, where S of t is measured in millimeters, t is in days, from 0 to 60. The rate at which the height of the water in the can is given by S prime of t, which is here. Okay, if I want the height of the water in the can at the end of the 60-day period, what would I have to do?
You have to integrate from 0 to 60.
Great, from 0 to 60 of
S prime t.
Okay. And I believe this one is with the calculator again because we are question 1. So I'm going to throw that up. Two sine 0.03x plus 1.5. We are going to integrate. From 0 to 60. Okay, so I've got 171.813. What are my units?
Height is millimeter.
Okay. Then for part B, I want to find the average rate of change.
So average rate of change is 1 over 60 integration from 0 to t S prime t. S prime t. So we just divide 60 from question A.
Okay. Is 2.864. And what are my units?
Millimeters.
Okay, not millimeters.
Oh wait. Oh, millimeters per what is time unit? Days.
Millimeters per day, perfect. Okay, part C.
So, assuming no evaporation, what is the rate of volume water in can change in t equals 7? So we're finding d over dt. And then, since it is the cylinder, wait, do we know the volume of the volume equation for cylinder?
It wasn't given, but what should the volume equation of a cylinder be?
Cylinder is pi r squared times height.
Okay, what's the radius?
10 millimeter.
And what's the height?
Oh, we have to get it from S prime t.
S prime t is not height.
Oh, st.
St. Okay, so I've got a general form for the volume.
And then we integrate it. No, we derive it.
Okay, what's my derivative?
So 2 pi r times dh over dt, because r is the constant.
If r is constant, then why do I have 2 pi r?
Oh, pi r squared times dh over dt.
Okay, cool. So that's 100 pi times s prime. Okay, and then to answer the question?
Yeah, so 100. So we're finding v prime t. So you just plug in the equation.
What am I plugging in?
F prime 7 is equal to 100 pi times s prime t.
S prime.
T, 7.
7. There we go. Okay, and we can put that in.
Yep.
So we've got our y variable at 7 times 100 pi. Or 602.218. What are my units?
Volume is cubic millimeter per meter. No, days.
Cubic millimeters per day. Perfect. Okay, last one.
So apply the intermediate. So at which height the water in the two can change in the same time. Okay, so apply the intermediate value theorem to the function d on interval this. Oh, that means when m prime t and s prime t are equal, right?
Okay, so we're saying there has to be a time such that the heights of the water in the two cans are changing at the same rate.
So when m prime t and s prime t are equal.
Okay. So how can I prove it?
So m prime t is wait.
If m prime t and s prime t are equal, what would dt be?
dt?
Mhm.
Wait, but it's like then it's gonna be double prime.
Just dt would be... Okay, dt is m prime t minus s prime t.
Mm-hmm.
So you said if m prime t and s prime t are equal, then what would dt be?
I don't know. It doesn't work like that.
If m prime t equals s prime t,
And then we divide by dt.
don't need to divide by dt, but what would dt be equal to if that's what is true?
M double prime t. No, 0.
0. Okay, so if dt is 0, then both of these rates are the same.
Yep.
Okay, now I want to use the intermediate value theorem on dt to prove that there is a point t where dt is 0. What does the intermediate value theorem tell us?
So if the function is continuous at some intervals, then there is a point where f prime x is equal to 0.
That's the mean value theorem, I think. Mean value theorem says if we're continuous and differentiable, then there must be some point where the derivative is equal to the average slope.
Oh yeah.
Okay, intermediate value theorem talks about the y values. So
Then we find d0 and d60.
okay, so we get d0 and d60. Okay, so I'm gonna pull a calculator again.
Mm-hmm.
Looking at this really quick before I pull this away, what is m at 0?
M at 0 is m prime 0 minus s prime 0.
Okay. What would m prime at 0 be?
0.
M at 0 is 0, but m prime at 0 is not 0.
Oh, it's... Wait, we have to use calculator.
We could, but what would it be right now if I derive it at 0?
So 9 over 400 t squared.
Okay, and then t is 0, so that term would cancel.
And then the second one also.
Okay, second one also cancels, and third term?
330 over 400.
330 over 400 minus s prime at 0?
So sine 0, 1.5.
1.5.
Oh, that's gonna be negative number.
Yep. Negative 33 over 40, which is negative 0.675.
And D60 is calculator. M prime 60 minus S prime 60.
Okay. So what do I have to type?
Math 8.
Okay, I'm gonna throw my m here really quick. So this is 1 over 400 times 3t cubed
Mm-hmm.
minus 30t squared plus 330t. Okay, and then you said I'm gonna break out of this and do math 8. So the derivative of
60.
okay, so that's variables, y variables, function y2. I'm gonna derive y2 in terms of x at x equals 60.
Mm-hmm.
Okay, and then I want to subtract s prime at 60.
Yes.
So what am I subtracting?
So S prime 60.
Okay, right now s prime is already my y1.
Uh-huh.
So that's variables, y variables, function at 60. Okay, that was a little bit tricky just because we had different units. So I'm deriving one, I'm not deriving the other in the calculator because this one's already a rate.
Yeah.
Okay, the other one was height. Okay, so this is positive 69.37.
Oh, so there is some point where passes 0.
Okay, so give me a sentence and tell me why.
So, if the function, no, according to intermediate value theorem, um, mm, there is some point where passes dt dt equals 0.
Okay, intermediate value theorem has one more condition.
Oh, continuous and differentiable.
Not differentiable, just continuous.
Oh,
Is this function continuous?
yes.
Okay. As dt is continuous and d0 is negative and d60 is positive. Okay, so we proved that we were above the point and below the point and that we're continuous. Therefore, there has to be at least one point where dt is 0. Okay, I'm going to go ahead and add that we're on the interval too.
Mm-hmm.
On the interval from 0 to 60. Okay, so according to the intermediate value theorem, there is at least one point where dt is 0 on the interval from 0 to 60, as dt is continuous and d0 is less than 0, and d60 is greater than 0. All right, any questions on anything from today?
Nope.
Okay, so homework for today is going to be part 2 and 3 of the free response that I just sent on WeChat and Skype.
2 and 3?
Yep, so that's Form B for this year, Form B of 2011.
Okay.
All right, and then I'll see you tomorrow for physics.
See ya.
Bye.